Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we will be talking about our question number nine of our network interview preparation series. As you all know, that we have been really working hard for our upcoming network interview. And in most of the network interview, this question is quite common. Why behind MSS and MTU, right? And believe me, for many network engineer, it's a nightmare. And also, this concept is very easy. I will prove this thing in this lecture. So what we are going to cover today, we will be talking about why behind MTU and MSS. We will be talking about the relationship between MTU and MSS, because you all know MTU is at layer 2, MSS is at layer 4. So we need to connect them, how these two layers are communicating with each other, right? It's going to be really interesting topic, right? Then we'll be talking about MSS and TCP, how maximum segment size is related to TCP. And then I will be talking about an MTU mismatch problem. And we will be seeing this as in a real network, that what exactly will happen if there is a mismatch of MTU, right? So if you give me your next 1 hour or maybe 40-50 minutes, I'm not sure how much time I'm going to take for this video, but if you give me your next 40 to 50 minutes, right? These things are going to be, the concepts are going to be with you forever. One more thing I would like to recommend, that if you are watching this question number 9, right, right, directly, and you are new to networking, believe me, it is not going to make any sense. You need to complete the remaining 8 questions, because those are not just questions or explanation of those questions, those are the concepts of computer networking. Just go through them and then come to this video number or question number 9, right? But if you are having a little bit experience in computer networking, then of course you can watch this directly. So without wasting any time, let's go to our board number 1, right? Where I will talk about why behind MTU and MSS, right? So first thing first, let's try to understand the topology first. We have laptop A here, we have laptop B here, right? And I have connected them with some of the devices like switches. You all should know by this time that this is my switch and this is my router, right? And you can argue with me also that, Mr. Vishnu, don't you know this? That we cannot connect directly a laptop with a router. I totally agree with you. But if I insert another switch in between here, then then this diagram will be quite lengthy, right? And if that is the case, it will not fit to the frame. So just try to understand the concept, right? I do get it that we cannot connect, or we do not connect generally our laptop with the router. But be with me. Let's try to understand the concept. So let's see what exactly there is inside this host A. We all know that if this host is communicating over internet or communicating to other host, it must be having TCP/IP, right? And where exactly this TCP/IP is inside this computer itself, right? In the form of a software. We call this software as TCP/IP stack. And this software or TCP/IP consists of 5 different layers: application, transport, network, data link, and physical. But if you see this switch, I have showcased only 2 layers, which is physical and data link. If you see the router, we have shown 3 different layers: network layer, data link layer, physical layer. Of course, at the end, we again at the laptop, so I am showcasing you 5 layers. But now the question is, Mr. Vishnu, why are you not showing all these layers in switches and router? And the answer is with you, right? You already noticed, or you mentioned this many times, that router is a layer 3 device. It means that it understands till network layer. It understands data link, it understands physical. We all know from the previous questions, right? And switch is a layer 2 device. That is why we have drawn, or I have showcased only 2 layers. As simple as that. But believe me, this is the classical definition of switches and router. This is what they do. But in current situation, if you consider, if you take a Cisco router or Cisco switch, there we have all the networking layer implemented, because in current world, switch also does routing. And you must be thinking, Mr. Vishnu, why? Why we are calling switch as a switch, right? We can have a debate on that, but classical definition of a switch is it understands till layer 2. Classical definition of a router is it understands till layer 3, right? But now let's come to the point. What is the meaning of Mr. Vishnu, this MTU and MSS? So this is a total picture, whatever I would like to explain you here, right? Now, let's talk about first thing first. We have connected our computer or laptop with this switch, right? This laptop is having, suppose the interface is 0/1. Believe me, you can argue with me, Mr. Vishnu, there is nothing called 0/1 in laptops, right? These concepts are numbering schemes are from switches or router. You are right, right? But I'm just giving it a name. Suppose the NIC card where this Ethernet wire is connecting is known as with 0/1, right? And on that NIC card, there is one value which is written. The value is 1500. That on this wire, you cannot send an IP packet if it is an IP packet, right? Or if we consider data which is coming from above layer, you cannot send more than 1500 bytes, right? From where this number came from, 1500, it is there, right there in the history, because this protocol is quite old. We decided on this number almost in 1980s. If we have to decide this number again in today's world, this is going to be really huge, right? But now we are talking about the convention. We are talking about by default what exactly the maximum this number is configured. The meaning of this number is you cannot send more than 1500 bytes of data on this wire. But believe me, many network engineers interpret it in different ways. They say basically in whatever the unit of data which is going on this wire should not be more than 1500. It is not the case. Now try to understand what I'm saying, right? So I am thinking this concept, whatever you are configured here, this 1500, right? This 1500 byte of information is known as actually maximum transmission unit. But believe me, till now, most of you guys are still confused, and I will remove that confusion, right? So what is happening at data link layer? MTU is equal to 1500. I'm talking about maximum transmission unit, which is configured at data link layer, which is 1500, which you can see over this interface 0/1. MTU is equal to 15. What is the meaning? The meaning is if network layer is giving some data to data link layer, it should not be more than 1500 bytes. This is the exact meaning, right? If I draw a packet, right? So suppose network layer is sending some data to data link layer. So what is this? From here to here? From here to here is data. Data for what? For data link layer, this is what I am getting as data. But if you see inside this, which I am getting from network layer, this is nothing but the IP packet, right? And inside the IP packet, what things could be there, right? It might be the case that we have IP header. And if the data is coming from the application, then of course we will be getting the TCP header also, right? And what about the data? Data may be anything. But overall, if I see from the perspective of data link layer, this complete thing from here to here is data. Data for what? Data for data link layer. Guys, if you have seen my previous questions in this series, you should be comfortable with this. I think you are comfortable with this, right? So I am just saying that the length of this data which we are getting from the network layer, the length of this IP packet, right, should not be more than 1500. Why? Because I cannot send more than 1500 bytes of information according to the MTU. MTU definition is whatever I'm going to get as a data from the network layer, it should not be more than 1500. As simple as that, right? It means that can this wire take more than 1500? Because this question should come to your mind, right? Because this is the IP packet, and IP packet doesn't flow over this wire, but a frame should flow because this is the Ethernet wire. And if it's an Ethernet wire, then the Ethernet frame should go over it. And what exactly the Ethernet frame contains? Ethernet frame contains source MAC, destination MAC, and then the type or length field. Source MAC is your 6 byte, destination MAC is your 6 byte, type length field is your 2 byte, and of course there is a trailer too, which is of 4 bytes. Interesting, right? It means that 1500 byte we receive from top, if I talk about data link layer, and data link layer put on top of it what? 6 plus 6, 12, 12 plus 2, 14, 14 plus 4, 18. 18 bytes of more data. It means that over this wire, all the time, 1518 bytes of data is traveling, right? So this wire can take more than 1500, right? Because it needs to have Ethernet header. I think the confusion is solved. Wire can take 1518, or this NIC can take 1518 without any doubt. But MTU means that you cannot have more than 1500 bytes of data from network layer or IP, because mostly the network layer IP is prominent. Everywhere you see IP, it means that IP packet cannot be of more than 1500 bytes. If MTU is 1500, as simple as that. But it doesn't mean that the wire cannot have more than 1500. Wire can have more than 1500 because we need to include Ethernet header also, as simple as that. So guys, this MTU, where whatever we have written, this maximum transmission unit of this host is 1500. This is at layer 2, right? Right? And this is your maximum transmission unit. And it is exactly the size of IP packet. Any IP packet which is more than 1500, and if we have configured 1500, cannot go out unless we do some other thing like fragmentation. As simple as that. Now, let's talk about, we are done with the MTU, right? But if you have a question that why, Mr. Vishnu, on earth we have this number 1500, right? Why it can't be more than 1500? Because I am sure that these wires can carry more than that data, right? But the problem is this computer A NIC, right? If we talk about around 1970s or 80s, these NICs have pretty less memory. At that time, at that point of time, you all know that when we receive a packet, right? NIC has to store it so that it can check, it can calculate the checksum, it can see whether the error is there in this frame or not, right? So NIC has to store these packets into the memory. And at that point of time, 1970s, 80s, 85, right? Memory was less. And that is why we decided on this little bit less number, although there are some more things, right? On which we have decided this 1500 value, but 1500 is quite standard, right? But if you see the data centers now, we all know that now these servers network interface card, routers interface card can have many much, can have really great amount of memory. And if that is the case, we can have more MTU nowadays, and that is why you see 9000 MTU and so many, right? So other value, but this is the most common value of MTU, right? Now let's talk about the second concept, which is maximum segment size, and let's talk about this on computer number V. And this is actually the concept at transport layer, which is known as MSS. So if I give you a brief idea, that MSS or the transport layer will be getting data from application layer. And this data is kind of a free flow, right? Or in a stream. So suppose I have a bucket And if you consider this bucket as your transport layer, then application layer is sending data in the form just like water comes from top, right? Means in a stream, there could be huge data. If that is the case, transport layer needs to divide this data into multiple chunks, right? Because we cannot send this stream to network layer, because we all know at the end data link layer is expecting not more than 1500 bytes of data in a particular chunk, right? So we need to have these chunks. We need to create these chunks. At transport layer, we call that these chunks as segments. So this is going to be my segment number 1, segment number 2, segment number 3, segment number 3, segment number 4. But what exactly should be the size of these segments? So transport layer, one of the important responsibility of transport layer is it gets the data from the application layer, which is coming in a free flow manner, streaming, right? And that it chunks it. But what should be the unit of that chunk? Maybe suppose if we are getting say 10,000 bytes of data, right? And maybe transport layer decide, or the TCP decide, that we need to segment it. Maybe it can segment 10 chunks, right? And every chunk has 1000 bytes of data. It can do that, but there should be some algorithm, there should be some mechanism through which this transport layer understand that what should be the standard size of this segment. And that is what is the relationship between MTU and MSS, which we are going to discuss in next board. So here you go. What is the relationship between MTU and MSS? If you see here, we have this computer A, and I have now only computer A, and this computer is having all the layers with it, of course. And we all know for sure that in data link layer, we all know that the MTU is 1500. If we have connected a wire here on 0/1 interface, suppose, then 1500 MTU is configured, and by default this value is 1500, suppose, right? It means that when data link layer receives something from the network layer, it should not be more than 1500. What I am going to tell you in this board, I'm just talking about the relationship between MTU and MSS. Although those work at those two concepts works at two different layers, but there is a relationship. Because we all know for the fact that whatever the chunk we are getting from top at the data link layer, it should not be more than 1500. If that is the case, suppose we are getting few or some data from application layer, and application layer, when it reaches to transport layer decide to chunk or segment this data into 3 segments, maybe segment number 1, segment number 2, segment number 3. And I would like to showcase you one segment, what is happening at transport layer. So this is the segment. I'm not sure what is the size of this segment, but let's try to calculate. We all know this fact for sure, that transport layer is going to add a TCP header, because it cannot send this segment directly. It needs to put some information like source port, destination port, right? Sequence number, acknowledgement. I think you must have seen my previous question, right? Or answer to the previous question, question number 8. I've explained it in a great detail there. So this thing is nothing but is known as TCP header, and this header is of 20 byte, of course, right? If we do not consider any options, by the way. So 20 byte is this header. Now let's talk about what is going to happen at network layer. This segment, or this complete information from here to here, and for network layer, this is complete data, right? Will be received by network layer, right? What is going to happen? Of course, we will be having this segment number 1. After segment number 1, we will be having this TCP header. And when this TCP header, or when this complete information network layer want to send to data link layer, you all know that it is going to put its own header, source IP, destination IP, and so on. And that is known as IP header. That is also 20 bytes. This is also 20 byte. I am not sure about the segment size, right? But we will calculate it, don't worry. This is the actual amount which will be received by data link layer from network layer. And by the way, this is what? This is your MTU, right? So let's calculate what this MTU contains. This contains 20 bytes of IP header, 20 bytes of TCP header, you all know. Then I do not know what is the segment size of S1, but all this combined should be how much? 1500, because data link layer would not accept data more than 1500. As simple as that. If that is the case, then this will become 40 plus segment 1 size is equal to 1500. How much this segment 1 size should be to become 1500? And you all know S1 should be 1460, because if you add 1460 to 40, it will give you 1500. It means that segment 1 size should be 1460. It can be less than that, but it cannot be more than 1460. If it is more than 1460, you need to put TCP IP, which will give you result more than 1500 if you put TCP header and IP header. So the maximum size of the segment should be 1460. Here also 1460, here also 1460. It doesn't mean that the segment size cannot be less than that, but it cannot be more than that. And that is what is known as maximum segment size. For IPv4, it is 1460, because the length of IP header is 20, length of TCP header is 20, which makes this 1500, which can be accepted by data link layer if 1500 MTU is configured. As simple as that, right? If I give you another example, right? If I give you an example of IPv6, believe me, in IPv6, the header length is 40, means 40 is the IP header length. Then 20 is the TCP header length plus segment 1. I do not know what is the size. It should be 1500 in this case also, because MTU is configured at 1500, you all know. If that is the case, in case of IPv6, S1 will be 1440. As simple as that, right? And suppose, what if instead of 1500 you have configured a 1400 MTU value, suppose you have changed the MTU value, you can change it. If that is the case, what should be the MSS? MSS you can easily calculate, because you know, right? The segment size, whatever you would like to calculate, right? It needs to be having IP, it needs to be having TCP header, and should be 1500. But now you have changed it to 1400. If that is the case, this should be 1400. If you had them, in case of TCP, in case of IP, this will be 40 plus, sorry, so sorry for that. Let me write it once again. Segment 1 plus TCP plus IP should be should be 1400 in this case, because you have configured 1400. TCP is 20, IP is 20, right? What should be the segment size so that it become 1400? Of course, it should be 1360, right? So if you change the MTU, right, we have to change the MSS also. It means that the transport layer and data link layer are talking to each other. By the way, this is the clear-cut example that how layers between TCP IP communicate with each other. This is the inter-layer communication between data link and transport. Or maybe the responsibility of this operating system, whenever this host comes up, laptop comes up, it will see that the MTU is 1500. It will inform the transport layer so that it can calculate maximum segment size by reducing or by subtracting IP and TCP header length. Why is that case? I think you get the idea. So this is the exact relationship between MTU and MSS, right? Now let's talk about a concept, right? That what is the relationship? What is the relationship, or how MSS and TCP is related to each other, right? So consider this topology. We have we have router here. We have router number 1, we have router number 2, and we have a complete network in between, which is known as internet. Maybe this is my host A, and this is my Google server, suppose, right? And what I want to do is I would like to make a connection with the Google server so that I can download its homepage. And for that, what I'm going to do, and there is no doubt about it, that whatever the communication will be happening, it will be happening like this, right? So we all know if we are doing HTTP or HTTPS, we need to make a TCP connection, right? From here to here. Just wait a minute. So sorry for this. Okay, so sorry for that. There was some glitch. So basically, you all know that from A to Google server, the communication will be happening just like okay, just like we see this line, right? The communication is happening like this, right? So if I want to download or do something or just download the homepage of Google server, what I have to do, I have to just send. So sorry, there was a glitch. So basically what I want to say here is that if A wants to communicate to Google server, the actual communication is happening on this through router, through internet, through router 3, and then, right? But if I want to download a Google homepage, you all know that first I need to make a connection. And to make that connection, I just need to send SYN, synchronous message. And what Google server is going to do, it will going to send SYN plus ECK. You all know what I'm talking about. I'm just talking about TCP three-way handshake, which you anyhow must have learned in the last question, which was the question number 8, which talk about sequence number, which talk about acknowledgement, right? And then the third message is going to be from A to this, right? Which is your acknowledgement message. You all know about it, right? But now the question arises, Mr. Vishnu, why are you talking about this here? Because very interesting thing happens when A makes a TCP connection. Inside the first SYN message, it says what is what its maximum segment size. Suppose it is 1460. It will be 1460 if we have configured, right? MTU is equal to 1500 on this interface. If that is the case, MSS for this host A is going to be this much, and host A is informing Google server in the form of SYN message that Mr. Google server, my maximum segment size is equal to 1460. Do not send me any segment which is of higher size than this, because this is my maximum limit, right? And suppose on the Google server also somebody has configured this as 1500. So Google server will be saying, okay, fine. My MSS is equal to 1460 also, right? This way during TCP three-way handshake, both the guys understand what is the maximum segment size, right? By announcing the maximum segment size, I just want to say the other party that do not send me more than this number, which is 1460. Now, suppose on Google, somebody has configured instead of 1500 MTU value as 1400. If that is the case, Google server is going to calculate the MSS as what? 1360, and this 1360 value will be going here in MSS, means here 1360, as simple as that. If that is the case, here my computer is saying to Google server, do not send me more than 1460 byte of segments, but the Google server on the other end saying do not send me more than 1360, right? And this is absolutely fine. You do not need to negotiate negotiate on this one, that the minimum, that for this connection the segment size is 1360. No, for A means if Google server is sending towards something towards A, it is going to be 1460, right? But if A is sending something towards the Google server, it is going to be 1360. You can understand this. Another example, suppose we have two guys talking to each other, A and B, and they are sending some important things, some boxes. A is saying B, did not send me more than 1460 kilogram of a box if they are exchanging box. And B is saying A, do not send me 1360 kilogram of box because I cannot handle that. I cannot lift it. As simple as that. So in TCP three-way handshake, the two parties which are making connections with each other, they announce their maximum segment size, right? Very, very interesting, right? And how they calculate now maximum segment size, I think you all know about it. Now, what I would like to do is, with all these concepts in your belt, right? Now you understand what exactly the MSS is, what exactly MTU is, what is their relationship. You also know that TCP, in TCP three-way handshake, basically we are exchanging this MSS value, as simple as that, right? Now let's see if we are on a particular network and if in that network there are MTU mismatch issues or MTU mismatch happens, right? Where exactly that MTU mismatch can happen, right? And what is the problem you might face and what is the solution for that problem, right? Let's see that on the next board. And so sorry for this. Here you go. This is one of the most interesting board of this complete question or the complete class. Again, I think the topology you already understood. Here we have computer number A. This is my Google server, right? Here I have configured 1500 MTU. Here also I have configured 1500 MTU, and you must be thinking, Mr. Vishnu, why? You are explaining us MTU mismatch problem. No, right? I just want to say that. So sorry, I am explaining MTU mismatch problem, but there is no MTU mismatch between A and the Google server. A is saying in this SYN message, my MSS is 1460. Do not send me more than that. This is saying to A, mine is 1460. Don't send me more than that. These guys are fine. But now try to think that on this router here, if I give them a name, suppose this is my R1, this is my R2. Here I have R3, R4, R5, and here I have R6. Suppose this is the case, right? Suppose somebody on R5 have configured a value which is MTU is equal to 1400 on this interface 0/1. If that is the case, is there any problem with respect to communication between A and the Google server? For that, just try to understand if I have a router and if I have an interface which is connected to an Ethernet wire, maybe 0/1, and I have configured or the default value is maybe 1500 MTU on it, right? The meaning is this router can only send 1500 bytes of data from IP layer, not more than that. And this is in transmission side, means it can transmit not more than 1500 byte the network layer data, right? And of course, it can put, suppose if it want to send the Ethernet frame on it, it is going to add those frame, means this can result into 1518 for sure, right? But 1500 is the thing which it can send from the network layer, but it can send it. There is nothing or no direction from inside perspective, how much it can receive from another router. It can receive even the greater amount of data, but, and that is why the name is maximum transmission unit, not maximum receiving unit. Maximum transmission means it can send this much, right? But it can receive much more than that. And this is the problem. This people do not know, right? So let's talk about now what is happening. So we have configured MTU is equal to 1400. The meaning is R5 cannot send IP layer data, which is more than 1400. Very, very interesting. So let's draw the packet. So A wants to communicate to Google server, right? Of course, it is going to create that IP packet. and it is going to put all these things, source IP, destination IP, and suppose the source IP is here, x dot x dot x dot x. I'm not writing everything, but you understand this is my IP packet. And of course, if I want to put this on this wire, I need to put an Ethernet header, right? And this is my L2. Interesting. And maybe let's say this is y dot y dot y dot y. So this data is going from x dot x dot x to y dot y dot y dot y. As simple as that, right? What is going to happen? This packet will reach to this router for sure. Router will be removing the L2 portion, right? And I'm presuming from here to here the data is 1500, right? Which I got from network layer. So of course, this computer will be having all the layers at the network layer. Basically from here to here, the data is 1500, means IP packet is of 1500. And of course, I can put maybe 18 bytes more in the form of L2, which can travel over this wire. But IP data should not be more than 1500. I'm repeating this again and again because it should be in your mind till now, right? Or it should stuck to your mind. Now R1 will get it. R1 will remove the L2. It will see the IP packet on the basis of destination. Suppose it will try to send it to R3. And of course, on this interfaces or over this wire, it need to again put that Ethernet header, the different Ethernet header this time, right? If you do not get it, it means that you haven't seen my second and third video of this interview preparation series, where I'm talking about how do computers communicate. And now suppose we have selected at R3 that if this packet, which is going towards y dot y dot y dot y, which is a Google server, want to go to there, I will be sending it toward R4. At R4 also, I will be seeing the IP packet by removing this L2 header, and I will be forwarding it to R5. Now consider what is going to happen exactly at R5. R5 will be removing this L2, which is prepended by R4, or which is slapped by R4, right? And then it will be remaining with the IP packet. And how much this IP packet length is? 1500 is the length of the IP packet. You all know that, right? And here is my problem. If IP packet length is 1500, right? I cannot send an IP packet which is 1500. Why? Because my MTU is 1400. I can send the IP packet with only 1400 length, maximum 1400 length. And you are giving me 1500. It's a problem, right? So now router have two options. Option number one, it can divide this packet into two parts. It can say that 1500 packet can be divided into 1400 and 100, two packets. And by the way, this is known as fragmentation. We call it IP fragmentation because it is happening it is done by router. Router works at layer 3, means IP fragmentation at layer 3, right? But sometimes in the IP header itself, this host will write, do not fragment the packet, whatever happened, right? So inside this IP header, there is a field or there's a flag which is known as DF, means don't fragment. And if this don't fragment bit is set to 1, it means that under any circumstances, do not fragment this packet. So if the DF bit is set, option number 1 is gone, right? Router cannot fragment it into two packets. And if it cannot fragment it to two packets, what it needs to do, it needs to drop the message. So only two options. If don't fragment bit is not set, fragment it. If don't fragment bit is set, drop it. If that is the case, whatever this host is sending, right, it is going to be dropped at R5 without any doubt. It means that to break this entire network, consider the thing, right? To break this entire network, we just need to configure MTU is equal to 1400 on there, right? Or maybe to even lesser value, 1200, or maybe, right? If that is the case, it's a big problem, right? And you can understand also the importance of MTU mismatch. And this mismatch can happen in to any path, to any, for example, if I consider this as my path, right? From reaching from A to B or A to Google server, this MTU mismatch can happen at any point, at any router, right? Interesting. If that is the case, is there any solution to this problem? And absolutely, there is a solution to this problem. right? The solution is actually what happens when this R5, here we have R5, when it drops the packet, it does an intelligent thing. And what intelligent thing it does, right? It sends a message back, an IP message back to the source, and source is x dot x dot x dot x. Why? Because it knows which source packet, the because it just know that the packet it dropped has come from x dot x dot x dot x. So it is his moral responsibility to let A know that R5 or me, if I consider myself R5, I am dropping the packet because I couldn't forward it because of my MTU, right? So what exactly it is going to say, it is going to send an IP message back. And by the way, this message is nothing but the ICMP message. I think you have, if you have seen my trace route video, I have explained you ICMP there. There are different kind of message. One such message is known as that don't fragments bit was set, and I had to if I want to send it, I need fragmentation needed, but df bit is equal to set 1, and that is why I'm dropping the packet. And this ICMP message is known as fragmentation needed, but df is set equal to 1. Right? See, R5 is replying after dropping this message, right? I couldn't able to forward it because fragmentation was needed, and you have mentioned that fragmentation is not possible by setting the df bit is equal to 1. And when this message reaches here, computer number A knows that there is somebody who has dropped my packet. Why? Because fragmentation was needed here, there, right? And interestingly, this R5 insert one more information into this ICMP message, that why fragmentation is needed. Fragmentation is needed because my MTU was 1400 and you are sending me 1500, right? So A has all the complete information that somebody in the path between me and Google server has dropped this message, and the reason was that the MTU there was 1400, and I know that I am sending it with the 1500, and of course fragmentation is needed, right? But I have set the bit do not fragment, and most of the cases don't fragment bit is set. So what is the solution? The solution is that because now this host knows, right, that there is somebody who is dropping the packet, right? So he says, this host says that of course this 1400 byte was configured there. It means that I need to reduce my MTU length from 1500 to 1400 for this connection. And they can do it, right? Otherwise the connection is not going to be formed. Otherwise the packet won't be exchanged, right? Because this guy will drop any packet who is having MTU length more than 1400. If that is the case, this guy, computer number A, will reduce his MTU value 1400 for this connection, right? And it will inform the transport layer which is sending, which is which has configured 1460 MSS, right? So it will inform transport layer, no, this time your segment size is, it will be creating problem, reduce it, right? Because now instead of 1500, I can send only 1400, right? Because there is somebody in the middle who will be dropping the packet if I send 1500. That is why it is going to inform the transport layer, and transport layer will be reducing at MSS sites, right? And how much? You all know that transport layer will be have to create a segment. Then, of course, at TCP layer, 20 bytes of TCP, then 20 bytes of IP, and it should be now 1400 this time. If that is the case, S value will be 1360. So this way, basically your computer will inform to transport layer, reduce the maximum segment size for this connection from 1460 to 1360. Otherwise, there is somebody who is going to drop the message. By the way, guys, whatever you just saw is your path MTU discovery. In this, you try to find the maximum transmission unit or the minimum value of this MTU value which is configured so that you can adjust your MSS. Interesting. So what could be the case, right? First thing first, SYN plus SYNAC plus ACK happens, right? And then we start sending the data. Once we are sending the data and the data is more than 1500, then this router is going to drop us, and then basically path MTU discovery comes into picture. Because this router is sending you fragmentation needed message, you understood that I cannot send more than 1400 byte of data because this router 5 has configured MTU value 1400. That is why you need to inform your TCP or transport layer that, dude, just reduce the size of MSS, otherwise it's going to be a problem, right? So what we understood in this complete session, right? We discussed about uh, we discussed about MSS, we talked about MTU, we talk about the relationship between them, how TCP takes this MSS value so that other guys understand what my MSS is so that it cannot send more than that, right? Interesting. And then at last we see what is going to happen if there is a MTU mismatch in the entire path. One more thing, people ask that suppose the PMTU is done, right? PMTUD is done, and now I know that the 1400 I need to send. So basically the MSS should be 1360. So do I need to inform now the destination of the Google server that you do not need to send more than 1360 to me, right? No, we cannot do that because that is done in the initial handshake messages. That is done. So for these two guys, it's still 1460, right? But the host is intelligent enough to understand that no, we do not need to send 1460 because there is some router who is going to drop the message. I hope you have enjoyed this video. In the next video, we are going to talk about DNS. Having said that, bye for now.